section, but not today. Okay? That's why I've kind of split it up into two different pieces. All right, so talking about exponential functions, this is what we started with yesterday, and we said our exponential function was y equals ab to the x. But if we're going to model it, we have a little bit more to that, right? If it is exponential growth, then we have y equals a times 1 plus r to the t. That should look familiar. Where r is your percentage as a decimal. If it is decay, that same equation, y equals a, but this one's 1 minus r to the t, where again, r is your percent as a decimal. So what happens is with the decay, 1 minus, you get this b value that is between 0 and 1, so it's decaying. All right, so with that in mind, I want to start with the first couple examples. Example number 1. On problems, we started at 3, so on problems 3 and 5, this is what I'm going to ask you to do. I need to know, is it growth or decay? And what is the, I want to show you word the same as the book, the percentage rate. So for example, if I give you y equals 3 times 0.975 to the x. This, if you look inside the parentheses, that is between 0 and 1, so this is a decay. Exactly. Good. Now I need to know what the percent is. So remember that this represents 1 minus our r is going to equal 0.97, right? So then we can solve for r. Technically, we would subtract 1, right? So you get negative r equals negative 0.025. Dividing both sides by a negative, r equals 0.025. So really, what is our rate as a percentage? 2.5. Now I'm going to put a percent sign there so we remember it's percent that we're finding. Do it again. What about this one? What if I have y equals 3.7 times 1.02, that's a 0, 295 to the x. This is a growth, I agree. And of course, growth is easier because we can see what's added on to 1, right? Because this actually represents 1 plus r. And so our r is actually 0.0295, but what is that as a percent? 2.95%. So the first couple of problems, that's all you have to do. Any questions? Do you need more examples? No? Okay. Oh, yeah, absolutely. There you go. You're welcome. So in the next section, we're actually going to write the equation, right? We're actually going to figure out what a is, figure out what r is, figure out what our exponent needs to be. Now, our exponent, I wrote it as t. I want to remind you that the way I used to say it is the exponent is the number of times it's happening, right? It's not just time, but it's the number of times it's occurring. So we need to think about that as we write our exponent, okay? All right. You're good? Okay. So here is example number 2. Let's say I have an initial value of, how about 52? The initial value is which letter? A. It's the number in front, right? It's the initial amount. Okay? And it's increasing, so that means it's growing, at a rate of, how about 6%? What was that? 6%. Let's just start off easy and say per year. That's an easy one. All right, so we have y equals the initial amount is 52. That's where our A is. Inside our parenthesis is 1 plus, and it's plus because it's increasing. 6% is a decimal, which is 0.06. And our exponent, how many times does it happen per year? Once. So I'm just going to put 1t or just t. Awesome. Yeah, just lean that right up against here. Yeah. Thank you. Thanks. Thanksgiving dinner tomorrow. Crockpot, that's why we've got this. You can plug in crockpots, making sure it's all taken care of. I'm not in charge. I'm just letting you have it in my room, so. Yeah, so next year you guys can plan yours. Every year. All right, so let's keep going. This one's pretty straightforward, right? So what if I change this up and set it 6% per day? Yes, it would change our equation to y equals 52 times 1.06 to 365 times t. Because what? Correct. So what that means is it's happening that many times every year, and the t represents the years you're doing it. Okay? 1 plus 0.06. 0.06 is your rate. Because why? I'm sorry, I'm not following your question. Say it again. No, go ahead. Say it again. I want to make sure I understand. Yes, just the exponent, and that was it. It's the only thing that changes. All right, let's try another one. Same idea. So example number 3. This is actually what you are doing for problems 8 through 18. Large chunk? All right, sorry, we're doing odds, so I guess that's 7 through, let me fix it. My bad. 7 through 17. That's what this is, yeah. Same thing. All right, so let's try this one. What if I said your initial value is 7, you're decreasing at a rate of 9%? Sure. 9%. Every 15 years? Sure, every 15 years. All right. So when we write this one, this is a great one. So we start off with our initial amount, so y equals 7. In our parentheses, since it's decreasing, it is 1 minus 0.09. Now, here's the trick. T represents a year, so really if it's every 15, 1/15 or T over 15. Okay, so what it's saying is if really we're only doing it for 5 years, your exponent's going to be 1/3, right? 5 over 15. Okay, it's a great idea. All right, let's do another one. Huh? It's because, okay, So the T represents years, right? This is saying it happens every 15. So over that big 15, it's only happening one time. So in order to get how much is happening each year, you got to divide it by 15, the exponent. Okay? Like still be this exponent would still be the same thing. Okay? So when you are going with more increments in a year, that's when you multiply it. So when we did the days, it was 365 days times t, because it was happening 365 times in 1 year. Okay? Because it's happening over 15 years, we got to take our year and divide by 15 to get how much is happening each year. Correct. Yes. So if it's smaller than 1 year, you're going to be multiplying. If it's bigger than 1 year that it's happening, you're going to divide. Okay? Let's do another one. How about, we'll just leave it underneath the same example real quick. Let's say we have, our initial value is 250. Let's go with it is doubling, which is not a percent, so we've got to decide how it's happening, right? And every week. How are we going to write this one? Right, y equals 250. If it's doubling, it's increasing, but it's not going to be 1 plus because I'm not giving you a percent, right? Now the doubling is just your b value. So in here, we're just going to say 2. If I was doing halves, we'd say half, right? Okay, so let's talk about the exponent. It's happening every week. 52 times t. We're good? Okay. All right. Let's go to, how about this? Example number 4. Write an exponential function for, and how about if I give you a beautiful table? Let's do -2, -1, 0, 1, and 2. And on this side, let's do what do I want to do? How about 9.0625? How about 7.25? How about 5.8? 4.64 and 3.712. All right, if I want to write an exponential function, first of all, you can see this is decaying, right? It's getting smaller. We know it's going to be a decay. But if I give you a table and I give you a list of x's and a list of y's, what do you think we're going to do? Plug in the calculator. So we're going into stat. Into edit. As if we don't do this all the time, right? This is list 1. This is list 2. Then you're going back into stat. Over to calculate. And you got to go down to exponential reg, which is like 10 or 0 or something. All right, so we're going to have y equals 5.8 times 0.8 to the x. Questions? How are we doing? All right, so let's talk about the last section you have up there. Any guesses what 33 through 37 must be? No. This is 19. There you go. All right, so I want to talk about the 33 through 37. Sample number 5. The population of, let's go, of Smallville in 2000 was, let's go with 4,200 people. It's a Smallville. Small little place. Yeah. The population is increasing at a rate of 3.1% each year. What will be the population in 2025? Well, what year was this from? 2000, so 25 years away. But we got to write our equation first. So this actually has two parts. First, we write the equation. Then we're going to plug in 25 for our year, our time. Okay? So we have y equals, our initial amount is how many people? 4,200. Is this a growth or decay? So 1 plus our percentage as a decimal, 0.031, right? And it is per year, so we just have t, or x, right? So this is our equation to begin with. Now, we want to know what it is in 2025, so what are we going to plug in for t? 25. So we have 4,200 times 1.031, just added those together, to the 25. 9,000 what? Of course, if you got a part of a person, you got the whole person. Well, then they're not counted in the population, right? All right, what did you get? I'm sorry. 9,010? All right. Granted, and I see where Mrs. Olmsted might be coming from. If she said if you only had like their finger, you're not really counting them in the population, right? Yeah, I agree. All right. So the last couple questions in that section are asking you to critically think about the information they're giving you. You can totally handle this. I know you can. No, you don't. No, it won't. You guys are going to be able to do 30. No, the last one's a little bit different, but I want you to look at it. I want you to read it. I want you to think about why, the ifs, ands, whys, what it could be, without me telling you and you guys just giving me the answer back. You know what I mean? You can do it. All right, go ahead and get started. You're on page 270, and I do believe I put it in Google Classroom already.